Okay, so 6.2 starts looking at some of the graphs of exponential models and some of the different ways they can be presented as a function. So I did two columns for you. We have growth versus decay here. And then I want to get into a money problem talking about investments with finances. So here's growth. I think it's pretty simple. Initial population, initial value, whatever you want to call it, and then your base, which is greater than 1. And let's take a look at the exponent as well. It's just x. So the second one here, we have an initial population of 100, and then our base is 1.02, so it's greater than 1, and again our exponent. Now look at this one. The exponent here becomes negative, and this is still in the growth column, and you have your initial value of 20. And the reason is, even though the base is 1/2, that negative, what happens when the negative exponent? It flips it. So that would actually be a positive 2. So that would be a growth. So now looking at the decay, we have a function that halves with an initial population that starts with 4. We have another one where the base is less than 1, and again a positive exponent. And so now let's create one that models this, only now for decay. So if I have 3 times, let's say the base is 4. If the base is 4 but you want it to be decay, then it has to be a negative exponent. Okay, so this would represent a decay function, because with the negative would make it 1/4. So take a look at these, make sure that makes sense, and you're going to have some problems within the homework that'll be like that. Okay, so our very first application that we're going to be looking at for exponential functions is going to be a finance equation. And typically the way this is represented is, as you see here, different books have different things. So what does everything stand for here? A is the amount you're going to have after a certain period of time. P is your initial investment, or remember now, P, if you look at and remember, y equals A times B to the x. A and P should look very similar. That is the initial amount. So we call this the principal. This is if the principal investment. If you have $1,000 and you want to put it in the bank, that would be P. The 1, that is standing for the 1 or 100% that you're adding. So it is always a growth. R is the interest rate. N is the number of compounding periods per year. So you may want to listen to this. N is 1 if it is a yearly, if it is only compounded yearly or annually. Semi-annually is 2 times a year. Quarterly, 4 times a year. Daily, 365 days a year, and so on. So I think you guys can understand that, monthly, how many months in a year? 12. So that's what N would stand for, and that will be described in every problem. T is how many years. These equations are very simple to figure out, and it may look difficult. The tough part is you're going to have to memorize this equation. Okay, so you're going to have to commit it to memory. The second thing is, when using the calculator to plug this in, be careful with parentheses. This needs to be in parentheses. Exponents need to be in parentheses. Okay, this all needs to be multiplied by p. So be very, very careful with your parentheses. On the next slide, I'll show you an example.